We now get to learn the last method for solving linear systems. The first way we learned was with graphing, seeing where they cross. Last time you saw how to solve by substitution, and the last way, and this is actually my favorite method, is to solve by elimination, which really is a lot like it sounds. We're going to be eliminating one of the variables and solving for the other. So let's go ahead and take a look at an example problem. So we have this system right here, 3x plus 4y equals a negative 2, and 3x minus 2y equals a negative 8. So let's go ahead and look through the steps and see what we need to do. Step 1 says make sure both equations are in standard form with the x and y's lined up. Well, standard form means that both x and y are on one side, so both of them are like that, so that's good. And then it also said we have to have the x and y's lined up, so we need to have the x's in a line, the y's in a line. We want the equation signs and everything else also in a line. So we want everything to line up. Step 2 says make sure there is a similar x or y term in both equations. Now it says it needs to be similar, but they don't need to be the same sign. So let's see if we have that. Well, we have a 3x in both equations. So that's good. So step 1 and 2 were already done for us. So let's take a look at step 3. Step 3 says eliminate one variable and solve for the other. So here's how we're going to eliminate. We're essentially going to be combining both equations together. Now this is why it's important that we have the same term in both equations so that we can eliminate that term. So I want to either add or subtract both equations together. So I want x to go away. Now because they're both positive, if I want them essentially to go to 0, I'm going to need to subtract them from each other. So that's what I'm going to do. I'm going to subtract the second equation from the first equation. So the way that looks is I'm going to go through and subtract everything. So 3x minus 3x gives us 0. So this essentially just goes away. So we've essentially done step 3 to eliminate one variable. Now we need to do a 4y minus a negative 2y. Well, those minuses just make it a plus. So 4y plus 2y gives us a positive 6y. And negative 2 minus a negative 8, those two minuses make a positive. So negative 2 plus 8 is a positive 6. So you can see that just by doing that, we eliminated an x, and now all we have is a y, and now we can solve for y. Well, 6 times y gives us 6, so y, of course, is 1. So we just did step 3. Step 4 says find the value we just found in number 3 and plug it in to solve for the other variable. So now the rest of the steps is essentially just like we learned in substitution. We found one of the variables, and we can just plug that back in to solve for the other one. And again, it doesn't matter if I plug it into the first equation or to the second equation. It will give me the same result. So let's try plugging it into the first equation. Sure. So the first equation is 3x plus 4. Here's where I'll put in my y equals a negative 2. So once again, we only have one variable, so we can solve this. Well, 4 times 1 is just 4. We have to get rid of adding 4 by subtracting 4. Negative 2 minus 4 is negative 6. Divide both sides by 3. So we get x equals a negative 2. Our second to last step, step 5, says the solution to the system is the solution for x and y. So our solution to the system is our x, which was a negative 2, and our y, which was 1. So remember, what this represents is this is the ordered pair that works in both equations, and if you graph both equations, this is where they cross. So our solution to this system is negative 2, 1. So let's take a look at step 6. Now a lot of you will want to stop at step 5, and that's okay. We got an answer, and you can just say that's your answer and move on. If you want a good grade, you're going to want to move on to step 6. Step 6 is just checking your answer. Now you can either check by graphing, so graphing both of those equations and seeing that yes, they cross at negative 2, 1, or we can plug them in and see if they work. I prefer the second one because it takes a lot less work. So we just need to see if negative 2, 1 works in both equations. So if I'm going to put in negative 2, 1 into first equation, wherever there's an x, I'm going to put a negative 2, and wherever there's a y, I'm going to put a 1. That becomes negative 6, 4 equals 2. So does negative 6 plus 4 equal negative 2? Yes, it does. So it works for the first equation. Let's check the second equation. So again, wherever there's an x, I put negative 2, and then wherever there's a y, I put 1. So does negative 6 minus 2 equal negative 8? Yes, it does. So we just checked our answer that yes, it really is negative 2, 1 by plugging them into both equations and showing that we get true statements. So those are solutions to both of those equations. We're now going to try another example, and I do apologize for the fact that I made some typos in this one, so you'll want to change the second equation to be 4x plus 3y equals a negative 4. I do apologize for that. So we need to go through using the same steps. So step 1 says make sure the equations are in standard form with x and y's lined up. So we need to change around this first equation because that is not in standard form. So I need to move that 2x to the other side. If I move that 2x to the other side, it becomes negative. So it would become a negative 2x. We still have our plus y, and we still have that negative 3 on the other side. So we can essentially rewrite this guy as this. And if you haven't noticed already, it won't matter in solving this if which equation's on top or bottom. So now we essentially just rearranged our top equation to be this bottom equation. Now, did we do the rest of number 1 and make sure the x and y's are lined up? Well, we have our x's together, our y's, our equals, and everything else. So we did step 1. Step 2 says make sure there is a similar x or y term in both equations, but they don't have to be the same sign. We don't have that, so we need to change them. We need to change one of them so that we can either change both or we can change one of the equations so that we have something similar in both of them. Well, just thinking really fast, there's a couple things I could do. I could either multiply everything in the second equation by 2 so that I have a 4x and a 4x, or I can multiply everything in the second equation by 3 so I'd have a 3y and a 3y. And honestly, it won't matter which one I do. You just kind of pick your favorite and go from there. I'm going to go with multiplying everything by 2. So let me show you what that looks like. I'm making an equivalent equation by multiplying everything by something similar. So I'm going to multiply everything by 2, because that's going to give me a negative 4x plus 2y, and then 2 times a negative 3 gives us negative 6. So now that we have this equation changed, I like to rewrite the system so it's a little bit cleaner looking. So we'll take our original one, our 4x plus 3y equals a negative 4, and put it with the one we just changed around. 4x plus 2y equals a negative 6. So now I can move on to step 3. Eliminate one of the variables and solve for the other. Now this time we have them with different signs. Our 4x's have different signs. So last time, since they were the same sign, we eliminated them by subtracting. This time, since they're different signs, if I want them to go to 0, I just need to add them together because they're already different signs. So I'm going to go through and I'm going to add everything. So 4x minus 4x gives us 0, so those go away. 3y plus 2y gives us a 5y. And a negative 4 plus a negative 6 gives us a negative 10. So now I just divide both sides by 5. And I get that y gives us a negative 2. So now that we have our y, we just need to plug it in and solve for x. So we just finished step 3. We eliminated one of the variables and solved for y. So now step 4 says take that value, take the value for y, and plug it in to solve for the other one. Now, we can plug it into either of these two, or we can even plug them into the original ones, the one before we mixed everything around and multiplied in it. It'll all still equal the same. So just essentially pick your favorite equation from all the ones we've been working with and plug in negative 2 for y, and we'll solve for x. So I'm going to plug it into the very first one because it doesn't really matter. So I have a 4x. Then here I throw in our negative 2 for y. And now I just need to solve for x. Well, 3 times a negative 2 is a negative 6. Add 6 to both sides to undo subtraction. That means I have a 4x equals 2. So divide both sides by 4. I get that x equals 2 over 4, or we can remember that that's the same as a half. Now, normally our last step is step 5 of just knowing that, oh, our solution is our x and our y. So our solution was 1/2 negative 2. And most of you will stop there. But if you want a really good grade, you're going to want to go on to step 6 where we check our answer. So I'm going to make some room and then we can check our answer. I need to check that a half and negative 2 work in these equations. So I just need to check both of them. So take the first one, put in 1/2 for x, put in negative 2 for y, and see if it works out 1/2 of 4 is 2. 3 times a negative 2 is a negative 6. And does negative 6 plus 2 give us negative 4? Yes, it does. So the first equation is good. Let's check the second equation. So wherever there's an x, I put in a half. Then wherever there's a y, I put in a negative 2. 1/2 of negative 4 is negative 2. 2 times a negative 2 is a negative 4. And does negative 2 minus 4 give us negative 6? Yes, it does. So we just check that our answer really is 1/2 or negative 2. And if you don't like checking it this way, you of course could always graph both of these equations and make sure that that is where those lines cross. Let's take a look at special solutions. One of the reasons that elimination is my favorite way of solving is because it really makes seeing special solutions so much simpler. We saw that there's only two special solutions. There can be no solution or infinite solution. No solution means that the lines are parallel, so of course they never cross. And infinite solutions means that they actually are the same line, so of course they're on top of each other and there's infinite amount of places where they cross. So last time when we were doing substitution, we saw that you had to go by the if you're getting something true or something false. But with elimination, because of the way that you always want to make sure your things are arranged, it's easier to see which one they are. So let's take a look at this first example. We have a 2x plus y equals 4 and a 2x plus y equals 4. Those are the same equation. So if they're the same equation when we graph them, they're going to be the same line. They're going to be on top of each other. Well, if they're on top of each other, they're crossing everywhere. So this is going to be your infinite solutions. Now, if you don't recognize that it's the same line and you go ahead and try to do your elimination, just everything's going to eliminate because you have the same thing everywhere and you'd end up with 0 equals 0, which is a true statement. So you could still go by that if you want to, if you don't recognize this right off the bat. Let's look at this one. We have a negative 3x plus y equals 2 and a negative 3x plus y equals 3. That means they're almost the same equation, just what's different is where the starting point is. So they're just a little off, but they have the same slope. Well, if they have the same slope, then they're going to be parallel. So if I didn't recognize all that, if I didn't recognize that it's parallel, which means no solution, and I just started trying to eliminate things, everything on this side is going to eliminate, and then we end up with something that's not true. So this, of course, means no solution. So that's one of the reasons why I really like elimination more than substitution as a method of solving, because as far as your special solutions, it seems a lot easier to see which one's going to be which. And that's it for elimination.